let's speak about black body radiation. Now let me say something about black body. A black body is hypothetical object, an imaginary one which doesn't exist in real life. It is a body which observes and emits all the radiation that fell upon it. It doesn't reflect anything. Uh, it is such a body, we call it a black body. Now, as I said before, there is no real black body in the world in real life, but sun is pretty much close to a black body. Now, by observing sun, by experimentally we grab the we grab this spectral energy density for its frequency. Spectral energy density is nothing but total energy for its per unit volume, and it is, and we grabbed it in this way. As we did experiments and we grabbed it in this way for frequency and spectral energy density. That's what we got experimentally. But uh, later on, Rayleigh and Jeans, they both came up with a formula based on wave mechanics uh, to describe this graph. And in this formula we can clearly see this is directly proportional to this, right? The space spectral energy density is directly proportional to its frequency squared. Let me first explain what this formula says. Here, this term is something associated with spatial energy density. It is equal to that, and 8 pi is constant, right? And k here is Boltzmann's constant, and c cubed is speed of light cubed, and T here is absolute temperature, and this is frequency squared. Now, uh, as the frequency V increases towards the ultraviolet end of the spectrum, in ultraviolet end of the spectrum is generally towards the right. This form when frequency is increasing towards it, this formula predicts that the energy density should increase as V squared, right? And also we can clearly see this is directly proportional to V squared, right? Frequency squared. And if you just imagine what this formula says, we can clearly get to the idea that this spherical energy density becomes infinite when frequency of the light also becomes infinite. That means when frequency of the light becomes infinite, the spatial energy also becomes infinite. That's what Rayleigh-Jeans graph shows, right? But this is what we observe experimentally, which is against the formula by Rayleigh and Jeans. Now this problem is solved by Planck in 1900. In 1900, Max Planck came with a formula. Uh, we described this exactly. In that formula, he assumed that light is made up of distinct uh, chunks called quanta. In this formula, he assumed that energy is not continuous, but it is quantized. It is released in something like packets, and that in just executing the formula, we exactly get the observed we exactly get the observed graph. Now let me sum up this whole discussion. It was actually Rayleigh and Jeans who first came with a formula to describe uh, black body radiation. He came up with formula as per wave mechanics, and as per wave mechanics, the observations, it is not exactly coinciding with the experimental results. And later on, Planck came up with idea in which he assumed that light is quantized and it is released in in distinct chunks, and that formula exactly coincide with the observed results.